Chapter 2 Screw Gauge. Experiment number 2. Aim of the experiment: A. To measure the thickness of a given glass plate, and B. To measure the area of cross sections of a given wire using screw gauge. Apertures required: first, screw gauge; 2. Piece of glass plate; third, piece of wire. Formula: thickness of the glass plate PSR plus n into L dot cmm, where PSR is pitch scale reading, n is corrected head scale reading, LC is least count of screw gauge. Area of cross sections of given wire is equal to pi r square mm square, where r is the radius of wire. Descriptions: a screw gauge consists of U-shaped metallic frame. To the left side of metallic frame, a fixed solid stud S1 is attached. To the right side, a hollow cylinder is attached. Over this hollow cylinder, parallel to its axis, a thick line is engraved. This line is called index line or datum line. Below the index line, a small scale is engraved in millimeter. This scale is called pitch scale. Inside the hollow cylinder, there is a groove and it acts as a nut. There is another solid cylinder over which there are threads corresponding to the grooves so that it can be rotated to move forward or backward. Hence, it acts as a screw. The tips of the screw is flattened and to the head of it a cap is attached. Around this cap there are 100 graduations and it is a circular scale. This scale is called head scale. As it is attached to head, a rated arrangement is made to the head of the screw for optimum gripping of the body between the studs. Theory: the screw gauge works on the principle of screw in a nut. In a screw, rotatory motions converts into linear motions. The distance between any two successive threads is equal to pitch of the screw, or the distance moved by the screw in the nut for one complete rotation is called pitch of the screw. When the head of the screw is divided into 100 divisions, then the distance moved by the screw for even 1 upon 100th of a complete rotation can also be measured accurately. This value is equal to least count of the screw gauge. Least count is equal to pitch of the screw upon number of divisions on head scale. Least count of screw gauge: the distance moved on the pitch scale for the rotation of one division of the head scale in called least count of screw gauge. U-shaped metallic frame. 2. Anvil fixed stud. 3rd. Spindle movable stud. 4th. Barrel. 5th. Index or datum line pitch. 6. Pitch scale. 7. Head scale. 8. Thimble head. And 9. Rated. Figure of screw gauge. Zero error when the two studs of the screw gauge are in contact. A. If the zero division of head scale consists with index lines as shown in figure 2, there is non-error. Zero error is equal to 0 and zero correction is equal to 0. Index line no error. B. If the zero division of the head scale is below the index line as shown in figure 3, the error is positive and the correction is negative. Index line positive. C. If the zero division of the head scale is above the index line as shown in figure 4, the error is negative and the correction is positive. Index line negative error. Figure 4. Procedures for finding thickness of glass plate. First, determine the error in screw gauge and its value is noted. Second, the correction for the error is noted. Third, the head of the screw gauge is rotated through certain number of complete rotation and distance moved on pitch scale is noted. Fourth, note down the number of complete rotation. Fifth, pitch of the screw is calculated. Sixth, the total number of head scale division is noted. Seventh, least count of the screw gauge is calculated. Eighth, the given piece of glass plate is held between his studs gently. Ninth, the visible value of highest division on the pitch scale is noted as pitch scale reading PSR. 10th, the number of head scale division coinciding with the index line is taken as observed head scale reading. 11th, correction is added upon subtracted to this to get corrected head scale reading M. 12th, multiply the corrected head scale reading N and least count to get the fraction of pitch scale reading. 13th, the fraction is added to the pitch scale reading to get total reading or thickness of glass plate. 14th, changing the positions of the glass plate between the studs, 6 readings are taken. 15th, average thickness of the glass plate is calculated. Procedures for finding area of cross sections of wire. First, the same procedure is to be repeated by replacing piece of wire in place of glass plate and average diameter D is calculated. Second, radius of wire is calculated by using R is equal to D upon 2. Third, area of cross sections is calculated by using from formula A is equal to pi R square. Observations. First, zero error of screw gauge is equal to dash divisions. Second, zero correction of screw gauge is equal to dash divisions. Third, distance moved on the pitch scale is equal to dash mm for 5 rotations. Fourth, number of complete rotation of head is equal to dash. Fifth, pitch of the screw is equal to distance moved on the pitch for 5 rotations upon number of complete rotation of head is equal to. Sixth, total number of head scale division is equal to. Seventh, least count of screw gauge LC is equal to pitch of the screw upon total number of head scale division is equal to. Therefore, LC is equal to dash millimeter. Table for thickness of the glass plate. Table for diameter of the wire. Result. Precautions. Questions. What is the principle of screw gauge? Second, how do you find the zero error? Third, what is meant by pitch of the screw? Fourth, what is the formula of least count of screw gauge? Assignment. Viva questions. First, what is the working principle of screw gauge? Answer. It works on the principle of screw. The rotational motions is converted into translational motions. Second, what is pitch of the screw? The distance between two consecutive threads of screw or the distance moved by the screw tips for one complete rotation of the screw is called pitch of the screw. Third, what is the least count of screw gauge? The ratio between pitch of the screw and number of divisions on a head scale is called least count. Or the distance moved by the screw tip for the rotations of one head scale division is called least count. Fourth, which instrument is used for measuring the thickness of very thin objects? Answer is screw gauge. Fifth, can we make the zero error cancelled? Answer is yes, by rotating the screw in the fixed stud with a screwdriver. Sixth, Is the screw gauge a direct measuring instrument? Answer is yes, the reading directly gives the measurement. 7th, among screw gauge and vernier calipers, which is more sensitive? Answer, screw gauge is more sensitive. 8th, what are the errors present in the measurements made up by a screw gauge? Answer, the systematic error like least count error, zero error, and the random error like backlash error are present in the measurement. Ninth, how do you increase the accuracy of the measurement? Answer is by decreasing the least count. The least count error is decreased. Zero error is estimated and corrected. The backlash error is avoided by taking the average of number of readings. Thus, the accuracy is increased by decreasing the errors. 10th, why is screw gauge also known as micrometer? The screw gauge can be used to measure the dimensions of the order of a few micrometers, of the order of 10 to the power minus 6 meter. That is why a screw gauge is also known as micrometer. 11th, what is zero error of screw gauge? Answer, when the two studs are in contact to each other, if the zero of the head scale division does not coincide with the index line, then the instrument is said to have zero error. 12th, how to determine this zero error? To determine zero error, tips of the screw is kept in contact with the stud. Then first, if the zero division of the head scale is n divisions above the index line, then it is said to have n divisions negative error. Second, if the zero division of the head scale is n division below the index line, then it is said to have n division positive error. What is wedge? What is wedge in a screw gauge? It is attached at one end of the hollow cylinder. On rotations of retract, the tips of the screw moves linearly. It prevents undue pressures on the objects when kept between the studs for measurement. It works with the help of springs. 14th, how to find the volume of given lead shot using a screw gauge. First, find the diameter of the lead shot and then its radius using the formula 4 upon 3 pi r cube. We can find the volume of lead shot. 15th, what is backlash error? The linear motion of the screw is proportional to the rotational motion of the head. However, when this is not the case, the backlash error arises. Generally, if the screw is adjusted by turning it in one direction and then in opposite direction, it so happens that the linear motions no longer remains proportional to the circular motions. It means that for no change in the gap between the stud and the tips of the screw, the head scale reading undergoes a change which lead to an error commonly known as backlash error. 16th, how to avoid this error? For final adjustment, the screw is always rotated in only one direction to avoid backlash error.